Okay, so my stupid video got interrupted, so I'm going to finish up this problem right here. We have an x squared. Remember, we found that this was x squared plus 36 because I FOILed out the x plus 6i and x minus 6i. Those were two factors that I knew were going to work. So I multiplied them together to get this. And now I'm going to pull out what I know works, which is this, out from this big scary thing. So I have an x squared. I need an x to the fourth. So that gives me x squared. X squared times x squared is x to the fourth. X squared and 36 is 36x squared. And then change your signs. So now I have an x to the third minus a 30x squared plus a 36x minus 1080. Good heavens, my handwriting is horrible. Okay, I have an x squared. I need an x to the third, which means I'm missing an x. So x times x squared is x to the third. X times 36 is 36x. And then change your signs. That leaves me with a negative 30x squared and a negative 1080. So this is my last round because my degrees match. So x squared into a negative 30x squared means I'm missing a negative 30. So negative 30 times x squared is a negative 30x squared. Negative 30 times negative 36 is negative 1080. Change your signs and you get a 0, which we knew we would get a 0 because these two factors that I multiplied together worked. So I knew that those two things would work. All right, so all that's left is to factor down what I've reduced this to. So these two multiplied together was an x plus 6i and an x minus 6i. And then this factored down is an x plus 6, x minus 5. So that is the factored form of the original polynomial. That is the factored form of the original polynomial. So we're going to dive in and do one more from scratch. I've got x to the 6th minus 13x to the 4th minus 52x squared plus 64. And I want to factor the following, which means I want everything in sets of parentheses. So I'm going to have 6 sets of parentheses at the end of this thing. So what do I want to do? First thing is rational zeros theorem. I know that I'm going to use factors of 64 to start trying things. Descartes' rule of signs says I've got 2 sign changes. Okay, so I'll either have 2 real zeros that are positive, or I will have no real zeros that are positive. So we're just going to dive in and start looking. So I'm going to try a 1. And this is the new part of 5.4. If I find something that works, I'm going to try it again. Okay, that's the multiplicity part. So I have a 1, and remember, you've got to take care of the spots that are missing. So this is a 1, x to the 6th. I am missing an x to the 5th, so he's a 0. I got a negative 13. I'm missing an x to the 3rd. I got a negative 52, and I'm missing an x to the 1st, and then I got a 64. So here's a 1. So 1 times 1 is 1. That gives me 1. 1 times 1 is 1. That gives me a negative 12. 1 times negative 12 is negative 12. That gives me negative 12. 1 times negative 12 is negative 12. That gives me a negative 64. 1 times negative 64 is negative 64. That gives me negative 64. And 1 times negative 64 is negative 64, which gives me a 0. All right, so this is like everything that could possibly go well just went well. I need 6 answers. I just guessed and checked with the first one, and if you'll notice, I've got pairs that match. So this thing right here is factorable. Okay, so I do know that 1 was a solution, which means, I'm going to write it down here, x minus 1 is his factor. And now I'm going to factor this one down. So this was an x to the 6th. This is now an x to the 5th. So I've got 1 x to the 5th plus an x to the fourth minus a 12x to the third minus a 12x squared minus 64x minus 64. So it's just factoring by grouping again. What's common on your first two terms? I can pull out an x to the fourth. That's going to leave me with an x plus 1. What's common here? I can pull out a negative 12x squared, and that leaves me with an x plus 1. And then I can pull out a negative 64, and that leaves me with an x plus 1. So what do all three chunks have in common? An x plus 1. And now I need to break this down. These are squared, sorry. So I need two numbers that multiply to a negative 64 that add up to a negative 12. So I know that my signs are different. So I've got a 1 and a 64. Well, that's not going to work. I've got a 2 and a 32. That's not going to work. 3 is not going to work. I've got a 4 and a, good grief, my brain is shot. A 4 and a 16. Ooh, that's going to work. All right, so that will break down to x plus 1. And then I'm going to have an x squared plus 16 and an x squared minus 4. So at this point, I need to break this one down further and this one down further. So I have an x plus 1 from guessing and checking. I've got another an x minus 1 from guessing and checking. I've got an x plus 1 that I found here. This is the sum of two squares. So he's not an x squared. He's an x plus 4i, x minus 4i, and then this becomes x plus 2, x minus 2. So you've got 1, 2, 3, 4, 5, 6 sets of parentheses. And it just so happened that this was really, really pretty and broke down pretty easy. So that is 5.4, which means as soon as you're done with 5.3 and 5.4, you are ready for your test.